Welcome back everyone. Today I am going to talk about working with highly toxic substances. Let's get right into it. If you've seen at least one video on my Thyzoid Laboratories channel, well, then you know that I'm doing a lot of stuff with chemicals that are not just not harmless, but that are incredibly toxic, not just in the short run, but some of them also in the long run. So today I'm going to talk about working with highly toxic chemicals. Firstly, we have to differentiate between highly toxic and dangerous, because not everything that is highly toxic is that dangerous, and not everything that is not highly toxic is harmless. Highly toxic substances are substances that can kill you if you take just a really small amount. Let's say cyanide is deadly with about 100 milligrams, I can tell you exactly, but it can be considered highly toxic. Now, will it hurt you in the long run? Cyanide exposure repeated with let's say you just take 1 milligram of cyanide by dermal exposure over your skin. It's likely not going to cause any damage in the long run, and it's not going to kill you right now if you have contact with it. But there's also other compounds. We've got compounds like lead salts, water-soluble lead salts, like arsenic, like cadmium, and also compounds of mercury and other stuff I can't think of. These compounds will accumulate in your body, and they might not destroy your life right now, but some of them can lead to your brain getting severely damaged in the long run. And the bad thing about this is that you are not going to notice it. You are not going to notice your mental health deteriorating until it is too late. Those chemicals accumulate in your body. Let's say you take 1 milligram or you are exposed to 1 milligram of lead acetate today, to another milligram tomorrow, to another 10 milligrams next week. This stuff is not going to leave your body as fast as it entered it. Some of it will even stay in there indefinitely, but it's true that lead salts will stay in your body for a long time. This means that even small exposures can lead to this stuff being toxic, and therefore I have more respect of heavy metal chemistry than, let's say, of potassium cyanide. I respect lead acetate more than potassium cyanide, which has still to be handled with great care, but it will not destroy you in the long run, and it is not going to accumulate in your body. Do the safety measurements. While working with any sort of heavy metal salt, with lead nitrate, I always wear gloves, I always wear safety goggles, and I'm going to dispose of those gloves later on, and I'm going to wash my hands, no matter if I spilled something onto them or didn't. With arsenic, it's the same. While making arsenic trioxide, I even went as far as to wear a hoodie so no arsenic trioxide can land in my hair, and I also wore a gas mask because you would not want to inhale any of this stuff, because inhalation would be far worse than getting it on your skin. Other chemicals I have a lot of respect for are carcinogens. The dangerous thing about them is that you will not notice anything until it is too late. They're carcinogens, they are not proven to give you cancer, but they can heighten your chances of getting cancer at some point in your life, even if you were exposed to them just once. This means that with all of this stuff, I take enormous safety precautions. All PPE has to be adequately adapted to the chemical compound you're working with. And if that compound can cause cancer or accumulate in your body, you have to take even higher precautions, because such compounds tend to be extremely bad for you. With highly toxic chemicals that won't accumulate in your body and that will not cause long-term damage, I still take all of those same safety measurements like gloves and safety goggles, and while working with cyanide that could end up being volatilized, or that could end up coming in contact with an acid, which I always avoid. I'm also going to put on a gas mask to avoid breathing in any dust and any HCl vapor. This means that this compound can fuck you up in the moment, but it is not going to destroy your life. And I value my brain more than anything because it is great to be able to think about any subject abstractly, and you will only come to value this thing that you possess, your mental capacities, once you actually lose them. And I will not want to proceed beyond this point. You take it for granted that you can think clearly, but you shouldn't. And therefore you should always be safe with chemicals that could alter your brain chemistry. Before working with any compounds, you have to read the MSDS. If it sounds too dangerous for you to do, you push it aside and you don't do it. It's as simple as that. What you don't feel comfortable with and what you don't know about, you won't do it. Just don't. If it's a compound that's largely unknown, it's a different story. I planned to make something which I can't find anything on the web about. I'm still going to make it because it's very unlikely that this compound is going to be highly toxic, and it's also very unlikely that it's going to be a super carcinogen. I'm still going to take the safety precautions, but I will make it even though there's not a lot of information on the web. Because this compound I plan to make seems to be very similar to two other compounds which already exist and which were proven to be somewhat harmless. To sum up today's video, firstly, you always take the necessary safety precautions and you always take them. There is no excuse that you should take because it's about your safety and about other people's safety. Secondly, you read the MSDS about the compounds. If you don't feel confident with doing this, and if it's too dangerous for you to do, you just don't do it. Thirdly, great precautions have to be taken while working with stuff that could accumulate in your body and with stuff that is proven carcinogen. With all of those highly toxic chemicals, you have to put on your basic PPE. You have to put on gloves, you have to put on a lab coat, you have to put on goggles, you have to put on everything to avoid contact because some highly toxic chemicals, they could kill you if you just get a small amount of them on your skin, if you just inhale a small amount of them, or if you come into contact with them in any other way. You have to take these safety precautions even if they won't accumulate in your body, because even if they won't damage you in the long run, they could end up killing you, thereby still damaging you in the long run because you won't be able to experience anything anymore once you're dead. Before I end this video, there are some other chemicals I want to talk about specifically. We have barium carbonates. Barium carbonates isn't necessarily labeled as toxic, yet if you ate it, it would convert to the highly toxic barium chloride. Furthermore, radioactive stuff, you should basically just keep away from it because if you are working with a radioactive source that can generate particles, it won't be bad, but if you are working with any radioactive powder, it could end up getting volatilized, it could end up in your body, and once an alpha emitter, beta emitter or any other radioactive compound ends up within your body, it can do great damage. If it's out of your body, let's say you put your hands onto a block of uranium, it won't be as bad as if you inhaled a milligram of uranium metal powder. We also got a few minerals. There's stuff like lead minerals, arsenic minerals, mercury minerals. They are not necessarily labeled as anything toxic, yet they could be very toxic. Because for minerals, there's often an exception for how they can be sold. They won't have any GHS symbols on them, yet they will still contain, some of these minerals will still contain highly toxic chemicals, even if they are not labeled out. I wish all of you a great day. Hope you learned something new. Stay safe in the future. If you do chemistry, use basic PPE every time, at least gloves and goggles. Because if you don't, you are soon going to adapt to this and you will neglect using basic PPE when working with stuff where PPE really matters. Bye.